your very important chapter for your ICSE, that is work, energy and power, or work, power and energy. So let's get started. What we are waiting for? Then work. What is work? We all know. In a daily parlance, the word work is used for some sort of exertion, physical or mental, or for various such as writing, reading, eating. We say that we are doing work, our own work. हम कहते हैं ना कि हम अपना काम करें, हमको तंग मत करिए, ये आप कहते हैं, ज़रूर कहते हैं, a normal upward. So that is only. So work is said to be done when the force applied on the body makes the body move. That is when there is displacement of the body. Displacement मतलब जब वो body move करता है. Work is said to be done when the force applied on the body makes the body move. That is the displacement of the body. Displacement means the fixed position where the body was fixed. Like this book is here, and when I am moving, the position I move is the displacement made by the book. Okay, and the force I applied is the force. Work I had done, that is the I moved the book. So that is the force. So work is said to be done when the force applied on the body makes the body move. That is, there is displacement of the body. And now there are several conditions when work done is zero. Like like if you are pushing a wall, then there is no work done since it is fixed. So there is no work done. So that is the condition that uh, there is no work done. Okay. अच्छा. So, work is said to be done when the force applied on the body makes the body move, and there is displacement of the body. That when I apply the force, it makes the body move, and there is displacement. So that is the main motive of this page. Okay, what is work? Work is said to be done when the force applied on the body makes the body move. That is, there is displacement. When I move this book, there is displacement. That is, it is moving. So that is the displacement position. Next. So next, very important, that is measurement of work, the magnitude of force applied and displacement of force. Magnitude of force applied. Now to understand magnitude of force applied means the amount, the power of force applied is dependent on the work done. The displacement produced by force. Okay, displacement means when I move this book, there is a displacement. That is called the displacement. Okay. Next, if forces F1 and F2 move two different bodies across the same distance, work done by F1 is said to be more than F2. So now, in case you see, now I am giving you an example. Two coolies are working, bearing loads. Now one is moving faster than the another. So what will happen? Work done is same, okay, but the power applied by the first coolie is more. Thereby, coolie 1 and coolie 2 has done the same work, but the coolie 1 has applied more power. Therefore, he has done it more quickly. Okay. Now, amount of work done of a force is equal to the product of force and the displacement of point application of force in the direction of force. Now, when I am moving, the displacement will be in the direction of force applied. Okay. Now, if displacement in the direction opposite, there is a retarding force. Okay. Then Fs cos theta is -1. That is retarding force you are applying. Okay. So that is called. It is saying on book, in your book it is written that if the displacement should be in the direction applied and point of application of force, that is in the direction of force applied. Okay. Now, expression. Okay, if a force acts on a body, the body does not move, that is displacement is zero, then no work is done. If a force acts on a body and the body does not move, that is displacement is zero, then no work is done. Example I am giving you. If we push a wall, no work is done since it is fixed. Now when I am moving this book, my Mobile is in my hand. When I'm moving this mobile, work is done. Why you know? Because it is moving. There is displacement. Therefore, the work done is there. But if it is fixed position, like in your house there is wall, okay, if you push that, no work is done. Since it is fixed, no work is done. You are applying power. You will tell that I am doing work, but there is no work is done. And then what type of, I told you that if it is opposite to the direction of force of light, like I am pushing this side and it is coming, and it is retarding application of force, like it is retarding, opposite, so it is retarding. Okay. Achha. Next is W is equal to Fs cos theta. Very important expression for work. Okay. It is not necessary that a force always causes displacement of the body in its own direction. Under some situation, a force displaces the body that is other than direction of force, then we determine the amount of work done by the force, either of the two ways, by finding the component of displacement of the body and the force direction is in the body. Now component, now you see, when you push this body, the component depends on the force applied. Now it is a heavy component, then more force is required. Whereas if it is a less weightable component, then less force is required. And that is, it is telling that it depends on the component. Now by finding the component, here you see displacement we are assuming as S. Now when we are pushing this brick, this side displacement is going on. Now if this come down in the retarding position, there is no work is done. Okay, that only I am telling. That is the most important part. Now W is equal to F into S cos theta. W is equal to F into component of displacement in the direction of force. Okay, now by finding the displacement of force, that is W is equal to F into S cos theta. Now some in your most of the numerical there is A F S cos theta का आपको प्रयोजन नहीं है, क्योंकि the most important formula is work done is equal to mgh, that we are going to learn afterwards. Mgh, work is equal to mgh. Next, okay, we'll come to the examples. Okay, I told you that time mg mass and gravity in free fall of a body of mass m under gravity through height h from a to b. The force of gravity F is equal to mg, direction of displacement force. Now you see, when I am filling this pen, now the displacement is normal direction of force of gravity. Okay, that is why, yes, that is why the wait, yes, that is why the displacement is normal direction of force of gravity. Okay, when I'm filling this pen, so it is normal, this side gravity is there, and when I'm filling this, it is normal direction of force of gravity. Therefore the displacement is normal. Therefore what we can say, work is equal to mg. Mg is mass into gravity. Now height, W is equal to Fs is equal to mgh. What we know, work is equal to force of displacement, and force is equal to mg. When I am applying force, force is giving m, mass is falling, and g, gravity means normal direction of force of gravity. Therefore force is equal to mgh. Okay, so W is equal to Fs is equal to mgh. When I am falling, force, mass, gravity, and height. Therefore work is equal to Fs is equal to mgh. If you are not able to understand, you can पहले से आप देख सकते हैं. Okay, so next I told you this example, like pulley does work on the load when raises up against the force of gravity. वो example, what example, that is दो कुली है जो आपका एक जल्दी जल्दी जा रहा है और एक आस्ते से जा रहा है. तो यहाँ पर वर्क डन इज सिमिलर, यू नो, वर्क डन इज सेम, but the power applied by both the pulley is different. Why you know? Because power applied by pulley 1 is more than the pulley 2, because work done is similar but power applied is more. Why? Because pulley 1 has done it more efficiently, more faster. Therefore power applied is more. Next, yes, same. Oh yes, this example is very important. If your book, open your book and please mark this. Okay, when a coolie works on a horizontal, give reason can come. Okay, from here, why there is no work done when coolie is working, taking the load under his head. Okay, over his head. When a coolie works on horizontal ground while carrying a load on his head, no work is done against the force of gravity, because the displacement of load is normal direction of force of gravity, which is vertically downwards. This is very important. That is, wait, I think it is mistakenly done. Subscribers, I think, mode. Anyone can check. Yes. Okay. So it is mistakenly I have done. Now next, When a coolie works on a horizontal ground while carrying a load, there is no work done. Why you know? Because coolie is standing in the direction of force of gravity and the load is normal direction of force of gravity. Now holding this, okay, this is normal direction of force of gravity. Thereby the displacement is normal. Thereby no work is done. ये अगर आपको समझ में नहीं आया है, आप थोड़ा सा आगे लेकर वहाँ पर से देख सकते हैं, आपको समझ में आ जाएगा. तो when a body moves the circular path in a horizontal plane, no work is done since the centripetal force on the body at any instant directed to the center of the circular path. Now, पहले आपको समझना पड़ेगा कि सेंट्रीपिटल फोर्स किसको कहते हैं. सेंट्रीपिटल फोर्स इसको कहते हैं जो फोर्स towards the center of circular path. Okay. Force assumed by an observer moving in the body to be acting on the body in direction towards the center. That is called centripetal force. And the force assumed by the observer to be acting on the body outwards, away from the center of circular path is called, centrifugal force. Please do learn these definitions, that is centripetal force and centrifugal force. Centripetal force is the force to be acting on the body towards the center of circular path, and centrifugal force is the force acting on the body away from center of circular path. So centripetal force and centrifugal force, very important forces. Okay, you should learn these definitions. Okay, we are coming now. Conditions for the work done by force to be zero. When the work done is zero, very important. When there is no displacement, that is S is equal to 0. Now, when you are moving a wall, you are trying to move a wall, okay, push a wall, then no work is done. Why? It is fixed. And when you are moving a book, like your textbook, you are holding in your hand, you are moving like this, then the work is done because you are able to move it. There is displacement, S is equal to some value is there. So displacement is there, so there is work done. But when work conditions for work done to be zero, that is S is equal to will be 0, and when the displacement is normal to the direction of force. Yes, when the displacement is normal to the direction of force. For example, जब मैं yes, displacement is normal direction of force, that is theta is equal to 90 degree. Displacement 90 degree के एंगल पे, मतलब ग्रेविटी के डायरेक्शन पर होगा. लाइक व्हेन द डिस्प्लेसमेंट लोड एंड नॉर्मल डायरेक्शन फोर्स ऑफ ग्रेविटी. लाइक जब मैं पेन को गिरा रहा हूँ, जो पेन ग्रेविटी के इफेक्ट में गिर रहा है, तो नॉर्मल है, इसीलिए नो वर्क इज डन है. तो दिस इज द कंडीशन. नाउ if displacement is in a direction opposite to the force, that is theta is equal to 180 degree, then cos 180 degree is equal to -1. W is equal to minus F into S. Work done on the body is negative. I told you, when displacement, the work done on the body is negative, I told you at the beginning. You can replay my video and you can see if you don't believe. I told you. Now I have a bottle of water. So this is a bottle of water. Okay, if I push it that side and if it came this side opposing my force, try to understand at this point. Okay, very important point. I am pushing the bottle this side. Okay, now if this came this side, in spite I am applying force, then work done is 0. Why? Because it is retarding force, no work is done, and the work done is negative, not positive. Now positive negative work, type of work you should understand, very important. What is positive type of work and what is negative type of work? Positive type of work, when you are pushing something, like you see this bottle, okay, bottle of water I have. If you are pushing this side, so if this is going that side, then positive work is done. Okay, and if in spite of my application of force, if it comes this side in spite of my force applied, then work done is negative. मतलब ये आपका जो फोर्स अप्लाई किया आपने, उसके डायरेक्शन नेगेटिव आ रहा है. मतलब फोर्स आप अप्लाई कर रहे हो, उसके बावजूद वो आपके तरफ ही आ रहा है, इसको हम नेगेटिव फोर्स कहते हैं। और ये टॉपिक बहुत ही इम्पोर्टेंट है आपका, जो आईसीएसई में इस टाइप का क्वेश्चन आएगा आएगा, हाँ आ सकता है, वेरी इंपॉर्टेंट है। सो इसको पढ़ना मत भूलिएगा। नेक्स्ट, वर्क इज इक्वल टू एफ एस इज इक्वल टू एम जी एच। ये एक्सप्लेनेशन मैं आपको पहले ही दे चुका हूँ, वाई वर्क इज इक्वल टू एफ एस इज इक्वल टू एम जी एच, येट आई एम गिविंग यू अनदर टाइम, प्लीज डू लिसन इट केयरफुली। When we are holding our pen, now this is a pen, we are falling, okay, work is equal to, sorry, yes, work is equal to fs, we are failing it, okay. Now work is equal to fs, force and displacement of force equal to mgh, force is equal to m and g. Understand this point of application, okay, if you understood it, how, why force is equal to mg. Now when we are applying force, there is mass, this is mass, okay, and as is what is the g, gravity, that is it is moving towards the point of gravity, therefore force is equal to mg. And displacement, why we tell displacement mgh, because displacement is the distance that we moved, okay, like this is the distance we moved, the position it moved, therefore work is equal to fs is equal to mgh. Thus work done by force gravity is same whether the body comes down from a certain height using stairs or slope or a lift or elevator. Next, units of work, very important points, you should watch it carefully. SI unit of work is joule. We all know joule, julie, joule, whatever you want to say, you can. But don't write the spelling wrong, then marks will be deducted from your sheet, answer sheet. Okay. Don't write the mistake in your spelling. Whatever you want to tell, joule, joule, julie, whatever, but don't miswrite the spelling. Since work is equal to force into displacement, I explained you just a few minutes ago, or 1 minute ago. Therefore, 1 joule is equal to 1 Newton into 1 meter. 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in its own direction. Now, 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in its own direction. Very important, very important definition, must learn, okay, very important, you should understand. Now I'm giving you the explanation, please do see. 1 joule of work, now 1 joule is unit of what, work. 1 joule of work is said to be done when force of 1 Newton, this is the body through within 1 meter, okay. I'm giving you a fun fact that is you all have noticed. Now when we buy anything, like a few days ago we went to buy our washing machine, so whatever, there is still one N, okay, in the bill script receipt, the receipt we got after buying, that is 1 N. What is N? Newton, okay. So that is 1 Newton is denoted by the quantity, okay. 1 Newton means quantity, is the SI unit of force and work. So bigger units of work are kilojoule, megajoule, gigajoule. CGS unit is dyne. 1 arc of work is said to be done when a force of 1 dyne displaces the body to a distance of 1 centimeter. So relationship between joule and arc, or joule, julie, erg, arc, whatever, joule, joule, jilly, whatever, arc, erg, org, whatever, but don't miswrite the spelling. My earnest request to you all is that don't write the spelling wrong. You can pronounce it anything, joule, joule, julie, erg, arc, org, whatever, but don't miswrite the spelling. Then marks will be deducted from your booklet, answer booklet. 1 joule is equal to 10 to the power 7 arc. This is a very important relationship between joule and arc. Should learn 1 joule is equal to 10 to the power 7 arc. Rate of doing work is called power. Power is a scalar quantity, measurement of power. Power spent by source is measured as the amount of work done by the source in 1. Power is equal to work by time, we all know, and now also we will learn power is equal to work by time. Now steam, I mean giving an example, power is equal to work by time, very important. Okay, honest request. Okay, one have joined. So I'm telling you that don't mistake the spelling. Okay, anything you can write, 1 joule, joule, julie, arg, erg, or, but don't mistake the spelling. Then marks will be deducted from your answer booklet. Okay. So next, power is equal to work by time. Then the power spent depend the following two factors, that is amount of work done by the source and time taken by the source to do the said work. Very important two factors. You should learn these two factors. Okay. Amount of work done by the source and the time taken by the source do the said work is the factor that the power depends. Next, power, I gave you the example in the beginning. B, a coolie, two coolies are there, coolie A and coolie B. Now coolie A and coolie B are given same weight, same load to be carried over the bus top roof, bus roof. Okay, coolie A does it faster, but coolie B took suppose coolie A takes 5 minutes and coolie B takes 6 minutes or 8 minutes, whatever. Suppose, and then imagine. So work done is same. Work done is same. You understand the point. But power applied by both, that is coolie A, is more, since he has done the work much quick, much faster than coolie B. Okay, this is the point, that is coolie A did it faster that when coolie B did it slower. Okay, so this is the point, coolie A has applied more power, therefore power is directly proportional to work done. Time taken by to do the said work is the, therefore I is the provement of the statement that the time taken by the source to do the said work. So power is directly proportional to the time to do the said work. Power. Next, now one condition is there. If a constant force acts on a body and displaces the body by distance s in the direction of force, then work done is equal to F into S. Okay, but S by T is equal to V, therefore power is equal to F into V. I will explain you now. So if a constant speed, like you see, constant means constantly a force is going applying, force applying. In that case, F P is equal to F into V, not power is equal to work by time. Units of power, you will learn this. 1 watt is 1 joule. Learn this. 1 joule is 1 second. 1 power spent is 1 watt. Okay. So 1 watt is equal to 1 joule per second, and 10 to the 7 are 1 horsepower. Very important. 1 horsepower is equal to 746 watt. Okay, 746 watt. 1 horsepower is equal to 746 watt. 1 horsepower is equal to 746 watt. Okay, don't forget, MCQ can come from this point. Okay, difference we will learn any two from these both cases. Work done by force is equal to product of force, this was the reaction force. Power of a source is the rate of work done by source. Work done does not depend on time. Power spent depends on time in which work is done. SI unit of work is joule, SI unit per watt. We will learn it. Okay, pretty important. I explained you. Energy of a body is its capacity to do work, and yes, energy of a body is the capacity to do work. There is no transfer of energy of body after about force normal. Okay, very important. Units of energy, SI unit of energy are same. SI unit of energy is joule or whatever, joule, joule, julie. CGS unit of energy is arg or arg, erg, or whatever. But don't miswrite the spelling. My honest request. Okay, you all don't miswrite the spelling. Anything you can pronounce. Next, watt hour. 1 watt hour is the energy spent of source or whatever. Okay, 1 watt hour is equal to 1 watt, therefore 3.6 kilojoule. 1 kilowatt hour is the energy spent for work done by source of 1 kilowatt in 1 hour. 1 kilowatt in 1 hour. Like if you are applying an iron, sometime earlier days, nowadays iron is 500 watt होता है, 500 वाट, यस 500 वाट होता है. पहले ज़माने में जो आयरन पहले बार लॉन्च हुआ था वो 1 किलोवाट की 1.5 किलोवाट हुआ करता था. तो अभी 500 वाट हुआ है हमारे ज़माने में जो चल रहा है अभी, तो वट एवर. Now, when you turn on your pump means your motor. Everywhere you have your tank in your roof, okay? You need to fill it by some means. That is motor, whatever pump, whatever. You tell it or tubewell pump, you fix it, okay? So in our home there is jet pump, whatever. Submersible, sorry, not jet, submersible pump is there. So pump draws up the water to your tank. Then it is supplied to your bathroom, your tap, your kitchen, your dining room, to your basin, so that you can wash your hand, you can use it, whatever. So a pump uses 1 horsepower energy, that is or 2 horsepower. Minimum energy taken by pump is 1 horsepower. पंप में एनर्जी 1 हॉर्स पावर के नीचे नहीं होता है, ये आप समझ लो. ओके, सो 1 हॉर्स पावर इनको 7 हॉर्स पावर, किसी भी पंप में 1.5 2 हाँ इतना हॉर्स पावर होता है. So calorie, what is calorie? We learn this year calorimetry in your calorimetry. Heat energy is usually measured in calorie. Heat energy is usually measured in calorie. 1 calorie is a work done. I am telling you, 1 calorie is a work done to raise the temperature of body from 14.5 degrees Celsius to 15.5 degrees Celsius. That is by 1 degree Celsius. You see, 1 calorie is required to raise the temperature of 1 gram of water from 45 degrees Celsius to 55 degrees Celsius through 1 degree Celsius. 1 joule is the amount of calorie. 1 calorie is equal to 4.18 joule. Don't forget, my dear students, 1 joule is equal to calorie. 1 calorie is equal to 4.18 joule. 1 kilocalorie is 1000 calorie is equal to 4180 joule. Okay, understood? 4180, 4180 joule. Okay, electron volt, the very important part in here. Energy transfer in case of atomic particles. Okay, atomic particles like atomic nuclear fission, you learn here in your class 10. Okay, energy transfer in case of atomic particles is very small that we cannot measure. So it is measured in sorry, let me take a sip of water. All right. So electron volt, that is energy transfer in case of atomic particles, is very small, and energy is measured in electron volt, EV. You can write it as EV. You see, EV, small e, small v. 1 EV is energy gained by electron when accelerated for potential difference of 1 volt. 1 EV is equal to 1.6 in 10 to the power 19 joule. Don't forget the students. My honest request is that 1 EV, electron volt, EV means electron volt, is equal to 1.6 into 10 to the power 19 joule. 1.6 into 10 to the power 19 joule. 1 EV is equal to 1.6 into 10 to the power 19 joule. Don't forget. Now, our last portion, because very big chapter this chapter is, so we will do only the first portion, that is A part, A and B, C. I will post another video. Energy of a body is its capacity to do work. Power of a source, the rate at which energy is supplied to it. एनर्जी स्पेंड डज नॉट डिपेंड ऑन टाइम. एनर्जी जब हम काम करते हैं, एनर्जी हमारे टाइम पर निर्भर नहीं करता है, और पावर निर्भर करता है. जो पावर हम पाते हैं हमारे जो करंट में, करंट तो एक पावर है, सोर्स ऑफ पावर है, वो पावर टाइम पर निर्भर करता है. क्योंकि आप देखो, जो पावर हम स्पेंड करते हैं वो आपके जो मंथली इलेक्ट्रिसिटी बिल आता है वहाँ पर आपको पे करना पड़ता है. सो पावर डिपेंड ऑन टाइम, डोंट फॉरगेट दिस. ओके, बट एनर्जी, हमारा जो काम का एनर्जी करते हैं, जो शक्ति हमको लगाना पड़ता है, वो हमारे टाइम पर डिपेंड नहीं करता है. ऐसा यूनिट ऑफ एनर्जी इज जूल एंड ऐसा यूनिट ऑफ पावर इज वाट. सो ऐसा यूनिट ऑफ एनर्जी का ऐसा यूनिट क्या है, जूल, और ऐसा यूनिट ऑफ पावर इज वाट. ओके, सो दैट्स ऑल. वी हैव कंप्लीटेड द फर्स्ट पोर्शन. Do practice see the numericals. Okay, tomorrow I will post the video. And if I forgot, please remind me by writing a comment, then I will remember. So that's all, students. If this video had helped you, then you know what's coming now. If this video had helped you, then don't forget to subscribe our channel. Okay, thanks for watching this video, students. Thanks. सब अच्छा रहे ना, हाँ, खुश रहो और सावधान रहो, क्योंकि दिस ये साल आपका बहुत ही वाइटल ईयर है, आपका ICSE एग्ज़ाम है आपका। सो बहुत अच्छे से रहो, पढ़ाई करो, आप बिल्कुल गुड मार्क्स आप स्कोर करोगे। हाँ, जय हिंद। और वीडियो हमारा स्ट्रीमिंग यहाँ पर खत्म होता है। एंड माई लास्ट अर्नेस्ट रिक्वेस्ट, इफ दिस वीडियो विद द फुल एक्सप्लेनेशन इन माई दिस लाइव स्ट्रीमिंग had helped you, then don't forget to subscribe our channel, students. Your own channel, ICC Edge, every time for you all to support you all. Thanks for watching this streaming, students. And my honest request, if this video helped you, then please don't forget to subscribe our channel and like the video. Thanks, students, for watching. Students, thanks.